So, good morning, everyone. Uh, I see the attendance is very low today. Yesterday, with the other class, there were 28 students who were participating in the online session. Okay, the first of all, why I called you is because I have to mainly pass on two instructions mainly. So, ensure that it is reaching the entire class through the groups or through the CR. It should reach all the 60 students in your class. First thing is, most of the many students have not attended the virtual lab sessions which was conducted during the practical. So those students who have not attended the virtual lab session, I want their roll numbers, and I'm conducting a repeat session on Monday. That is coming Monday morning at 9 o'clock or 10 o'clock. The timings I will confirm. That I have already texted you in the group yesterday itself that you have to attend that session. Those students who have not attended the virtual lab session earlier. Now ensure that I want the CR is messaging me the entire list of numbers. Ask the CR to collect all the students' numbers who have not attended the virtual lab sessions. It is compulsory because you cannot just like that submit the report. It is compulsory that you have to participate in the workshop and then submit the report simultaneously. So ensure that it is happening. Okay, just pass on the message to all the students. Second thing is I have updated everything in the what do you say, LMS portal. So I'll start sharing the screen now. You can see. Okay. So can all of you see my screen? One of you?
Yes, sir.
Okay. Okay. Fine. So first and foremost thing, if you see the LMS content, I have updated everything. And you can see that the lecture one and a video attached to it, then review of sequence and structure database and how to use PubMed videos, then about genome project videos, and so many research papers have also been attached to it. So in such cases, you can see that CBI BLAST video is there, then BLAST e-value, a discussion on the video is there. Then you can see that lecture 19 are two lecture 19s are there. One is a heuristic algorithm and the other one is a tea coffee method. So the research paper of tea coffee is attached for your perusal. Then iterative block-based element dialine 2 lecture paper, research paper is attached for your understanding. So on and so forth. I have updated the entire LMS portal. So everything which was discussed in the class is given in detail with the LMS portal. Now apart from that, there is a question bank session over here, but I'm not using this question bank session over there. Instead, I have attached it as a PowerPoint. Okay. Lecture 38, 39, 40, 41 sessions discuss about the question banks. Now, all of you see that on the right hand side, there is a mark. So this, I understand that many of the students are not accessing the LMS portals regularly. Because of that, I can see that many, this is the way I can track how many of the students have gone through the LMS portal. Okay. So please ensure that all of you are accessing all the slides. Stop broadcasting this thing, that one of you download the session and distribute to everyone. That thing will not work out here. Okay. You all have to access all the videos, all the exercises attached, all the presentations which have been given, and this should be enabled. For example, I'll show you one that I'm clicking on the discussion on unit 1 bank. Okay. So I have this lecture 38 and you can see that the questions are 2 or 3 mark questions and then 4 or 6 mark questions, and like questions, what all questions can be asked in 4 or 6 marks and all is being listed over here. Now once after accessing this material, when I go back, you will see that it is marked. That means I have accessed this particular question bank. So ensure that all of you are accessing this question bank, because I can keep a track, then only I can keep a track who all have accessed the material. So please ensure that all the students are accessing the LMS portal regularly from now on. You have a lot of time. Utilize the time properly. That I hope you have almost now 15 days left for the exams to start and all. I mean 10 days there for start, remaining for exams to start. You can start preparation properly. Just inform all the students that it is very, very compulsory that you should access the LMS portal for access of the information, and ensure that all the students are accessing entire thing. And I will be keeping a track of how you are accessing it all. I'll show it once again. So if I'm clicking on the MJ tree building method, if I want to see it, I can click on it. I can do this thing. I can view the portal. Okay, I have an option of downloading here. You can download the session if you want, or you can watch it online. So once you download the portal, then when you go back, it will be shown as you have already seen this particular slide. And this particular slide mark is compulsory for me to see. Okay. I want all the students to access this PowerPoints and all the PowerPoints, and I want to ensure that everyone is accessing from the LMS portal itself. Okay. So please tell the CR to communicate this to all the students. And the second thing, as I said in the earlier itself, virtual lab session, who all have not attended any of the sessions and submitted the report, it is compulsory for them to access the portal and access the thing on Monday. So I want the list of students. So the other class I've shared some.
Sir, for the batch C, the virtual lab session hasn't been done, and for batch D, I'll get you the attendance by evening.
Okay. So those of you who have not attended the session, no, the entire roll numbers I require. Yesterday, the batch A class 1 students shared me there are 31 students. So I'm expecting close to around 70 to 80 students to attend the virtual lab session on Monday. Okay. So
Okay, sir. And yeah, with those who haven't been done for the batch C.
Yeah. For those
we should also do it on Monday.
Yes, they should also be doing it on Monday. Okay.
Okay. At some specific time?
Yeah, I will be sharing the Zoom meeting time for that thing. All have to come online, probably at 9 o'clock or 10 o'clock in the morning. Okay. I will share share it in the class group, official group. The meeting invite I will be sending to all. Okay. So those are not should attend that thing. Okay. Yeah.
Yes, sir.
Now, so now I hope both the points are very clear. The question bank, I mean the LMS portal to be accessed and virtual labs. And yeah, one more thing, the virtual labs report, after doing the virtual lab reports, needs to be submitted as assignments. Okay. Now here I'll be posting the questions over here for the, I will be putting the facility for here, and you can upload the material over here. I'll be putting it over here, and this is my dashboard. So I will attach an assignment over here for the virtual lab session, and you can add your virtual labs report to that particular assignment section. Okay. The same virtual lab reports will be the one you will be taking the printout and submitting it in the journal as well. Is that clear?
Sir?
Yeah.
Sir, in the previous virtual labs, our report used to be about the principal aim theory introduction. So this time it will just be the answer of the questions you give us.
No, I will not be giving you the answer questions and all, because not all the experiments which we are doing in the virtual labs will have these things. Okay. So you have to do the same way only, aim, report, and activities, whatever you have performed and your understanding of what you have to do. I'll be giving you the
some of us already have some of us have already made the report and submitted to Mayur sir, Sagar sir, sorry.
Sagar sir.
And it is also checked also.
Okay, so you can upload the same report soft copy in the assignment as
well. Okay, sir.
Yeah, if you have submitted and then that can be uploaded in the soft copy as well. And you have submitted the feedback on the same day itself.
Yes.
Yeah, then it is fine. If you have not submitted the feedback on the same day of the workshop, and if you have submitted on the next day, then you have to ensure that you are attending this workshop, because anybody who have not submitted the feedback on the same day of the workshop, their numbers are not counted. IIT Bombay doesn't have that number. So when they communicate the number to us, your number will be missing, because any number less than 10 in a day will not be counted as per IITB standards in the workshop. Got it? So just ensure that all the students who have submitted the feedback have submitted it on the day of workshop itself. Convey this message very clearly to the students. There should not be any confusion. Okay? Pass on the message to the students that whenever the practicals was conducted for the virtual labs, on that same date itself, they should have submitted the report, the feedback report. If they have not submitted the feedback on that date, then their roll number will not be listed in the workshop. Then they will not, their workshop will not be considered at all. Their participation will not be considered at all. All such kind of students also must participate on Monday. Is that clear? Yeah. Can you hear me?
Yes, sir.
Yeah, fine.
Yes, sir.
Okay. So let's go to this thing. Okay. So now, importantly, why I called for this particular session is to discuss about doubts. So you can post your doubts now. You can ask your doubts, whatever you have from the sections which we have discussed in previous lectures. I'll be happy to clear all your doubts, and then we can switch on to the question bank if needed.
Sir, if we could have a short revision session, it would be good,
Okay.
if possible.
So let's start with the first. So we started our semester with the history and applications of bioinformatics. I spoke to you about what is computational biology and what is biological computing, isn't it? So in the computational biology, we discussed about the various applications of bioinformatics. If you see, uh, yeah, so if you can see the screen, I have updated I spoke about the computational biology and the biological computing aspects. In computational biology, we discussed in detail about the algorithm development, database handling, programming languages which are essential, how statistics is helping us in prediction in bioinformatics softwares, importance of machine learning, and how machine learning have improved the accuracy of the data retrieval in bioinformatics. And then we discussed in detail about the data mining and warehousing steps which we have to follow, isn't it? So, post that we started our discussions with the genomics, proteomics, sequence analysis, and sequence analysis became the major unit. That is second unit and third unit. We discussed about sequence analysis in detail, and in the fourth unit, the first unit and the second unit we discussed in sequence analysis in detail, and third unit we discussed about the one step ahead. We went ahead and we discussed about the gene prediction. And then in the fourth unit, we discussed about the homology modeling. Drug discovery per se, we didn't discuss in this semester. That is reserved for the next semester. So till modeling, we discussed in this semester, and the next semester, you'll be discussing more in detail about the drug discovery papers and all those things. Okay. So now, after discussing with examples on those stuff, we started with the review of the structure and sequence databases, isn't it? So we discussed that. 1 minute.
So, sir, the PowerPoints you've taught in class, if we read them and the other research papers and the videos you've uploaded, that is for reference, right? In case we don't understand, or if you want a more deeper understanding, then we refer the videos and the research papers you've given us, right?
Yes, yes. The research papers also you go through it, because if you carefully go through my presentation, I have shared that what paper where you have to discuss, whether you want to the abstract or whether you have to refer the full paper and all those things I have mentioned in my presentation itself. So you have to follow the instructions which are given in the presentation.
Okay, fine. So we basically follow everything that's written in the PowerPoint, and if we don't understand something, then we refer the videos, or if it's written, then we check up on the papers.
Yes, yes, yes. You can check on the papers, and also
Fine,
keep in
fine.
mind the reference books which I have mentioned in the class. That is.
Yes, sir.
Sir, regarding the reference book, I have one particular doubt, especially in the unit 4, the book which you had told that day with the author name Arthur M. Lesk, that we are not able to find in the internet for the book.
So that book is available hard. Okay, I have that soft copy with me. I'll share it with you.
Okay, sir. Thank you. Thanks a lot. Yeah.
So I'll share that. I'll share that reference book. Don't worry. So I'll repeat the books which you have to refer. One is the David Mount's Bioinformatics. For the second unit, like pairwise analysis in the book, that book. Then major part.
Your audios are taking off a little bit.
Sorry, come again.
So your audio has become a little unclear.
Yeah, it's become a little less volume suddenly.
Wait. Yeah. So now can you hear me properly?
Yes, sir.
So the first unit, David Mount the first unit is databases. So databases and databases, you can refer my PPT itself. And in that, some of the PPTs I have mentioned that you have to refer the question bank. I mean, the research papers, full research paper. And in some databases, I have mentioned to refer the abstracts. So follow that strictly. That should be sufficient. Then we started with the pairwise sequence analysis. So pairwise sequence analysis, David Mount book you can refer for Needleman and all. And then the algorithm, the Needleman algorithm and Smith-Waterman algorithm, you can refer my PPT itself, because there are multiple methodologies available on the internet space. So unnecessarily you'll get confused. To avoid that, you just see to it that you are referring to my PPT itself. Okay. So when we started our discussion after the databases, we slowly started unpacking, discussing on the pairwise sequence analysis. In the pairwise sequence analysis, we discussed about the homologous sequences and homology. We discussed under homology. Then we tried to understand about what are ortholog sequences and paralog sequences. Then we started our discussion with match, mismatch, and gaps, isn't it? So how the match score is determined for DNA sequences, there is no standard metrics to follow for the match score. So BLAST considers the length of the sequence and propose a match and the mismatch score we discussed. Then when we discussed about the protein sequences, we know that there is a standard metrics which we follow. That is about the standard metrics is PAM and Blossom metrics which we follow. They have studied, the scientists have studied the mutational properties of proteins properly in the case of PAM, and the scientists studied about the identity which they maintain in the case of Blossom, and those sequences, then the scores are generated and shared, and those are the scores which we use in the pairwise comparison and all. So after understanding the parameters, we started with the pairwise comparison. So in the pairwise comparison, we discussed on there are two types of comparisons. One is the global alignment, and the other one is the local alignment. In the global alignment, we discussed an algorithm called as Needleman algorithm. And I hope all of you remember how we saw that algorithm. It's very important. You should remember that thing. Then we discussed about the Smith and Waterman algorithm, which is a local alignment. Then also we discussed about the window-based approach, which is the dot plot, which is the easiest way to know whether two sequences are matching or mismatching, or should we go ahead with a dynamic programming approach for the sequences which you are having as samples. Because dynamic programming is very time consuming and computationally intensive, the applications of dynamic programming was restricted. Then we discussed in detail about how the PAM matrix is generated and how the Blossom matrix is generated. We discussed this. So that also you should remember how we construct the PAM matrix, PAM1, how it is constructed, and PAM-N, how it is constructed, we discussed. Then we started with the heuristic approach. So basically there are three approaches in pairwise sequence analysis. One is the window-based approach, then the dynamic programming approach, and the heuristic approach. So under window-based approach, we discussed about dot plot analysis. Under dynamic programming approach, we discussed about Needleman algorithm and Smith-Waterman algorithm. And under the heuristic approach, we discussed about BLAST and FAST. So BLAST, you all did the practicals as well, and I also showed you the slides of how the BLAST parameters make the change. If you see in BLAST N itself, there are three types of BLAST: mega blast, discontinuous mega blast, and BLAST N. So only the change, the algorithm remains the same, but the change is only in the parameters. And then when you talk about the the protein blast, then we have multiple blasts, different types of protein blast. One is psi blast, the other one is pi blast, and then delta blast. Delta blast was not included as part of the syllabus, but psi blast and pi blast are very much a part of the syllabus. We discussed about the blast algorithm, how it takes, what is the relevance of word length, what is the relevance of E value, how the word length starts searching on the databases. A particular length of word size is taken and searched across the database, and whenever there is a match, it starts extending on both the directions under the scoring system. As long as it is maintaining the threshold, the extension of the sequences on both the directions happens. So these are things we discussed in detail. Then we discussed the psi blast and the phi blast. Psi blast is position specific iterative blast. So we found out that from the first blast result, a particular pattern of a query sequence is generated from the results, and that particular pattern is used for searching further. You have done it in the practicals as well. Then in the 5-blast, what we do was that in side-blast, we generate the pattern out of the results. But in 5-blast, we went to flow side and we searched for the pattern and we used the pattern while searching in the 5-blast. So that makes a difference between the side-blast and the 5-blast, and then the iterations continue. So approximately 4 to 5 iterations which we have to do so that we get the proper alignment and proper sequences. Distantly related sequences. The basic difference between side blast and normal blast is side blast will help me in understanding the distantly related homologous sequences. Distantly related sequences which are ortholog sequences, which are close. I mean, other species sequences which are closely related. Okay. Then we discussed about the heuristic approach, where we discussed about the FASTA. FASTA algorithm was discussed in detail. And then I shared with you some so that brought us to the end of the first unit. First unit is an elaborate one. We discussed in detail all those things. Then we understand that pairwise sequence analysis is done with 22 sequences. Now, what if I have more number of sequences? So then we discussed with the phylogenetic analysis concept, multiple sequence analysis. So we understood the entire concept of multiple sequence analysis from the point of phylogenetic analysis. Because the major application of multiple sequence analysis is done in the phylogenetic analysis. The phylogenetic analysis itself is a big topic. In that, one of the steps is multiple sequence analysis. Hence, we discuss from the context of phylogenetic analysis. Then we try to understand the different parts of the phylogenetic tree. What are the different types of trees? Rooted, unrooted, then cladograms, dendrograms, all those things. Scaled rooted tree, scaled unrooted tree, unscaled rooted tree, unscaled unrooted tree, all those things we discussed. Then we discussed about the terminologies and all. And then we started on with the tree building steps. There are 4 steps. First step was identifying the marker sequences. Then we went for multiple sequence analysis, that is the step 2. Then we went for step 3, where we generate the tree. And then step 4 was the validation of the tree. So in the step 1, how to identify the markers and all those things we discussed, and then we started with multiple sequence analysis. In the multiple sequence analysis step 2, we discussed many algorithms. Again, dynamic programming algorithm was also there, heuristic algorithm was also there. Dynamic programming algorithm is very complex, very computational time intensive, and most of the time our normal PCs cannot perform a dynamic programming approach. So divide and conquer algorithm is the one which we discussed under the dynamic programming approach. And then, because there is a practical difficulty in understanding the dynamic programming approach, because there are practical difficulty in understanding the executing the dynamic programming approach, we went on with the heuristic algorithm. And under the heuristic algorithm, we discussed so many different tools. The one of the most important tool which we discussed was the first one was cluster tool. Cluster omega we discussed, cluster W algorithm we discussed. And then to overcome the difficulties of cluster W, we discussed about the T-coffee algorithm. And then there are, again, in that itself, heuristic itself, there are 2 types of this thing. One is the iterative alignment and the block-based method. We discussed about those methods and the tools associated with those methodologies and all, die-align 2 and all we discussed. And then we went on to the step 3 of tree building. So in the tree building, again, we discussed that there are 2 types of tree building methods. One is the distance-based method and the other one is the character-based method. In the distance-based method, we discussed in detail about the UPGMA tree building method and the neighbor joining method. In UPGMA tree building method, we took an example of bear, raccoon, weasel, seal sequences, and then we did it. And then in the NJ tree building method, we discussed about the we again took 6 sequences and then how it starts. It starts with a star-shaped tree, and then we find out the closely related sequence. We calculated the net divergence, and then we calculated so many calculations we did. I hope all of you remember that thing. You have to remember all this stuff. Then we discussed about the distance calculation method. One of the first distance calculation method we discussed was the Hamming's distance method. Now, post Hamming's distance method, we discussed about other distribution or substitution models as well, like Jutes-Cantor model, then Kimura's 2-parameter model, then some complex models also exist. And these kind of models are used for calculating the distances. Remember the formulas which we use for calculating the distances between the sequences. There are various theories behind which accept this can be used, this cannot be used in such kind of context and all those things. And then this was what we discussed in the distance-based method. Followed by the distance-based method, we started our discussions with the character-based method. In the character-based method, we discuss about two methodologies, particularly maximum parsimony method and maximum likelihood method. They both are computationally intensive methods, statistically intensive methods. So we didn't discuss anything about the algorithm parameters of it. We just took an overview of how the character-based methods work and when to use what. I showed you a flowchart on what is the context. If this is the case, which methodology to use. If this is the case, which methodology not to use. All those things in a flowchart was shown to you and discussed. Then we continued with the applications of multiple sequence analysis. I have attached the lecture 26. I have attached some, the question bank 1 and 2. Question bank is attached. The revision piece was taken. We have to discuss these things. So applications of multiple sequence analysis in the Federal Court of Law was also discussed. The paper attached to it was discussed. Then how it is used in biodiversity, how it is used in other contexts was discussed in detail. Followed by that, we started with the third unit of gene prediction, and then we started with the story of how complex it is to make a computational biology statement. For example, people come to a bioinformatics stating that anything is possible using computational techniques, but it is not so. How difficult and how accurately you have to make a frame a problem statement that we can go ahead with the computational biology tools is what we discussed in the beginning. Then we discussed about the gene prediction itself, how in prokaryotes it is done, how it is eukaryotes in that, what are the different methodologies, homology-based method and ab initio-based method. In ab initio-based method, what we do is we look within the gene itself and try to understand how it is, what are the gene content, which we have the gene signals, which we look into for gene prediction, and what is the content of the gene, that also we look into for predictions and all. So this kind of things was discussed in gene prediction. And then we went in detail about the algorithms used in prokaryotes and eukaryotes. I hope all of you remember that relatively the third unit and the fourth unit are very small units. So if we can manage to cover the entire concept of the third unit and fourth unit, that will be very good for you guys only. It will help you a lot in that unit. So relatively very small unit. Then in the fourth unit, we started with our discussion on the amino acid structures, basic amino acid structures, what is the protein, how peptide bonds are formed, what are van der Waals force, what is Raman-Chitrak dot, what are the different types of structures it forms, alpha structure, alpha helix, beta sheets, all those things, coils, pores, all those things we discussed. And then we started our discussion with the secondary structure prediction. In the secondary structure prediction, we discussed in detail about the Chau-Fasman method and the Gore method, and how these methods have used us in helped us in predicting the accuracy, predicting the secondary structure at high accuracy. And then we went on to discuss about the homology model. In the homology modeling, we discussed the Swiss model server and the steps involved in it in the last lecture. There are 7 steps, and all those 7 steps, what happens in the 7 steps is what we discussed. So when you click on the button on Swiss model server, what all things happens behind is what we discussed in the tertiary structure prediction or using homology modeling. And ab initio-based modeling is also there, but that is not a part of the syllabus right away. So that we will be discussing in detail, and the validation of the protein structures also in detail using GROMACS. We will be doing it in the next semester. So this is the general overview of what all things we discussed in the entire semester. Or in a nutshell, this is the content of the website. This is the content of the syllabus. These are things we discussed.
Thank you, sir. It's like really helpful. It was like glance.
You all must have gone through a flashback. What all things you have.
Yeah.
Yes, sir.
So whatever I highlighted, whatever I highlighted just now, these things you ensure that you are covering it properly. That the terminology, the names of the topics, whatever I have mentioned right away, can be. I am making a video of this particular thing, so I can share this video with the students so they can access that video and they can come to know what all we discussed today. Yeah.
Yes, sir. I just have doubt with this unit 1. Like the scoring kind of thing. We made that table, sir.
Which one?
Sir, for calculation, we did that table. We used to trace back the sequence scoring. We used to give scores based on upon like horizontally and vertically. We used to number the table. I'll just go through. Just a minute, sir.
Sir?
Yeah.
So I think he's talking about the Smith, the Waterman, and the basic alignment and the local alignment. The trace back we used to do. Like we used to make the table and then match the scores and then do a trace back. I think he has a doubt about that.
Local alignment, sir.
Local and global alignment. That's what you're talking about, right?
Yeah.
One second. So you were asking me about scoring system, scoring methods. So in nucleotide sequencer scoring, we don't have a standard metrics. Okay, so we assume a match score and a mismatch score and a gap score. So when it is a nucleotide sequence, we assume that on the basis. So generally, BLAST how it does is it considers the length of the sequence and then it says this could be the match score, this could be the mismatch score, considering the length of the sequence. But in the case of, excuse me. Yeah. So in the case of protein sequences, we have a standard method because they have studied the protein amino acid properties very clearly. So based on the amino acid information we have discussed about. So based on the protein sequences properties, they have generated two matrices. One is the blossom matrix and the other one is the PAM matrix. The PAM matrix, they consider the mutation. They have studied the mutation patterns of the amino acids and then generated the algorithm, generated the scoring matrix. And in the case of blossom matrix, what they done was they studied the identity of the amino acids. To what extent the amino acid will remain as such itself was studied, and then then the matrix was generated. So both of them can be used. One talks about the mutation properties and the other one talks about the identity properties of the sequences. So Blossom was relatively a new algorithm. After PAM, it was designed. So Blossom have considered little more number of parameters. Having said that, PAM is also widely used even now. Yeah.
Sir, I would, if we trace back from there goes two sequences, the matrix blossom, local alignment, and Smith and, sorry, sir. Trace back from, so like if we have two arrows pointed towards, like there's like two arrows from same number or same scoring, we get like if it's 10, and we get a vertical arrow and a horizontal arrow, vertical arrow facing upward and horizontal arrow facing left. So we'll approach both the sequences. We'll have to approach both sequences or one.
You have to do both. You have to write both the alignments.
And for local alignment, we need to consider the lowest or highest number, sir.
The largest number from the largest number, your trace back step starts.
Largest number. Thank you.
Yes. So any more questions? So what I'll do, I will share this particular video also in the group.
Sir, excuse me.
Yeah.
So what are the reference books for unit 3 and 4?
Unit 3, I told you to for gene prediction, right? Gene
Yes,
prediction
sir.
part, you can refer my PPT. That is the story which I told and all. That is a self-made one.
Yeah.
Mhm.
The second part of the thing you have to refer. Gene prediction is this
Sir, I saw the PPT, I got a lot of content in Zyong also. So can we refer Zyong for that?
young only.
Okay, sir.
Yes.
Yeah.
Right. I think we will call it. Whatever
Sir,
doubt.
Sir, just upload that unit for that reference book that you told you have the soft copy. Yeah.
I will upload it
Okay, sir.
so you can access that. Okay. I'll do that.
Yes, sir. Thank you.
Yeah. Okay.
sir,
Yeah.
sir, for PAM matrices, after the last step, after computing, normalizing mutability probability from X to Y, so the last step, the converting the mutability probabilities to log odd scores for X to Y. So there I'm facing a little bit of a problem.
Yeah, actually, that is a mathematical step involved in that thing. Hence, the reason I didn't go in detail on how it is considered. So you just understand the step that log odd scores of the x and y. That is the amino acid which we are comparing. Two mutations
Mhm,
amino acid we are comparing. For example, P is becoming Q. So that is a log
mhm.
x to y. Okay, the log or scores related to the x to y is considered, and then on the normalized score we implement the log or scores to generate the main algorithm, main values of the PAM is what it says. So in between there are a lot of mathematical calculations involved. So it will be a little difficult to understand to the code how it works actually now. You need to go back to the research paper and then see the derivative to understand it much better. So for your
O-
class, I felt that highlighting the steps would be sufficient. That's the reason why I highlighted only on this.
Okay, sir. Thank you, sir.
No more questions. So what I will do, I will stop this recording, and I will.
Sir, I have one last question. Sorry to disturb. Actually, sir, in Unit 4, that Chow-Frasman method, I didn't understand the concept of that propensity value. So can you just give it in a short way?
No, actually, that calculation I just showed it as a. It is not actually meant for you people. It was actually meant for mathematics students. The propensity calculation part, it is just an averaging of the values only, and it is
Okay.
to tell. I mean, in the screen, I won't be able to show it. Even on the day of exam, I can. If you can come 1 hour earlier, I can. Excuse.
Okay, sir. Okay, sir.
I
Yeah.
can show you the calculations.
So
Sir,
Okay.
Sorry.
कौन बोल रहा है?
you can continue, Ru.
No, I was saying, sir, actually, the concept of a position-specific scoring matrix, it's just after blast in our PPTs. So the position-specific scoring matrix is general. The concept I was not able to actually grasp, sir.
Okay. The PSS.
PSSM.
Okay. So the PSSM metric is actually what it is. I told you about the blast sequences in the first step. No? The first step, the blast sequences, one load a query sequence, and you are getting a lot of sequences attached. Similar sequences. You so based on the PSSM, based on the results, the PSSM matrix is generated. So it is actually calculating the distances between the sequences.
Mm.
Okay, the distance is made in the form of numericals. How do we calculate the distances? For example, in this case, we are calculating using the Hamming distance method. Okay, so the Hamming distance method, how it is calculated, and then how we got it. Yeah. So in the Hamming distance method, how we are calculating the sequence distance. Similar way in PSSM metrics also we calculate the distances. And again, PSSM metrics calculation as such, it is not meant for you. Again, I have shared the slides of bioinformatics students so that in case if you are finding it interesting, you can go through it. What I'm basically sharing that thing. Basically, PSSM metrics is calculated on the basis of the alignment score.
So it's okay if we can grasp the theory because the below calculation is just for reference.
Yeah, yes. It's given as an example only.
Sir, and I was saying that before this
Takunle.
606 is the last subject. So before the exam, there are 3 days holidays. So if we can't come right now, we can come then to clear our doubts, right?
Yes, definitely.
To the college.
Definitely.
Okay, sir. Thank you.
Sir, like if we approach with the PPTs and some of the research papers, as you mentioned, is it enough? Or like reference books, we'll refer to reference book more often.
You refer the reference books as well. That will be useful. That will help you a lot.
Okay, more of a reference book and PPTs.
Yes.
Okay, thank you, sir.
So guys, okay. So whatever you have on Monday, please pass the information. Remember to pass on the information to all the students. That all the students access the LMS compulsorily, and I will be tracking the access of all the students in the LMS. So even if any student is having no access to LMS, right away send an email to the LMS coordinator, that is Smita ma'am. Okay, you have to email Smita ma'am. The CR can take the charge and send it. Don't send individual emails. Whosoever's emails are not getting connected to LMS, contact the CR. Let the CR draft one email and send it with the roll numbers whose LMS is not getting activated or not getting access. Is that clear?
Yes.
Yes, sir.
Yes, sir.
And then
So
Okay,
for
sir.
the
Thank you, sir.
virtual lab session.
So for the virtual lab sessions, it is we are doing it on Monday or no on 23rd 9 o'clock, right?
Yeah. I will send you the message to the group.
So with all the details, right, virtual experiments we have to do, everything will be sent on the group, right?
Yeah, I will be sharing all what you have to do and all. I'll be sharing in that session.
Okay, sir. Thank you, sir.
Okay, sir. Thank you.
Okay.
We'll leave.
Good day.
Good. Thank you, sir.